And we've got massive filaments, coronal mass ejection warnings, and more on today's video. And thanks everybody for tuning in. Let's talk about some chemistry going on. These blue areas are ionized iron. The red areas are ionized helium. And we figured we'd take some composite imagery today because we've got these massive filaments and a coronal mass ejection warning. As a result, you can see the size of these filaments. These are like 20 Earths in diameter plus in length. And some of those will not remain in the solar corona. Some will end up in the solar system, perhaps a little closer to home. You can see one of the filamentary eruptions happening yesterday. We captured this on our Twitch stream on a different instrument, the NASA GOES 16 SUVI. Here's a colorized magnetogram. There's actually not a lot of solar activity in terms of sunspots happening. Likelihood of big flares is just not there. Here's 304 angstroms by itself. There are some coronal holes in the southern hemisphere down here, and they are about to put Earth back into a geomagnetic unrest condition if the BZ continues in its negative state. So anyway, the 10.7 centimeter radial flux is, I think, at 80 now. There's the 1 year chart of that from solon.info. The black line, that's the 10.7. Space Weather Enthusiast dashboard. Expecting some geomagnetic unrest a little earlier today. We didn't quite get to that, although we have a very high-speed coronal hole wind stream striking the geospace at the moment. Let's look at seismicity. And you can see from this 90-day chart here, that is what you call a 7 magnitude earthquake drought. Just to give you some historic perspective on that, here are some previous years. There's 2010, 2011, and you can see the space between large earthquake droughts is punctuated by large earthquakes. At the ends of those droughts, there is a very long one in 2018, and you can see a series of large earthquakes happened after that long drought. That's the 90-day bar graph. Let's see what's been shaken here. Nothing over a 6 magnitude, it looks like. Some 5s. Kermadec Island saw 5. Where are these? Azerbaijan and the Loyalty Islands both saw 5+ magnitude quakes. Kermadec Islands are located north-northeast of New Zealand. So yeah, it's sort of an earthquake lull here. A small deep quake at the Philippines, 4.9 at 101 kilometers. Yeah, largest quake of the past 24 must have been this 5.6 at the Kermadec Islands, it looks like. Next, volcanoes, while we're in the geophysics space here. The space on Earth can be important. La Palma is an interesting space. The massive volcano there producing an 8,000-foot ash plume. It's calmed down a little bit since our report yesterday. Subanose-jima, 8,000-foot ash plume from Subanose-jima as well. Semeru exploding, 14,000-foot ash plume from Semeru over East Java, Indonesia, Popocatépetl. Probably the top of my bucket list volcanoes. One of the closest volcanoes to my location here in Lehigh Valley. Volcanic ash not seen in satellite imagery. I'm not sure if it's a cloudy day there or not. Don't assume Popocatépetl is not erupting. Leave us a comment if you're viewing the video from Mexico. Santiaguito in Guatemala is exploding, 15,000-foot ash plume from Santiaguito, and that was not on the list yesterday, I don't think. Fuego exploding in Guatemala. That explosive activity has produced a flight level 170, a 17,000-foot altitude plume of volcanic ash. Sangay exploding, 20,000-foot ash plume from Sangay. That's located in Ecuador. Sabancaya of Peru, 24,000-foot ash plume from Sabancaya. Nevados de Chilean exploding, 14,000-foot ash plume from Nevados de Chilean. That's central Chile. Please don't pole vault the caldera. Which brings me to our featured product. Today's featured product, you can find the link to the smAsho merch at the homepage at smAshomash.com. There's a discount code going on all apparel. So perhaps pick up some Do Not Pole Vault the Caldera merch, perhaps a mini skirt. Our colorful design is quite high-res print. Tell your friends and foes to not pole vault the Caldera. This public service message brought to you by smAshomash.com at, quote, massive risk and massive expense, end quote. And don't forget to enter the promo code 25 off apparel to save 25% off all apparel through tomorrow, November 22nd. 25 off apparel. Do not pole vault the Caldera. Welcome to the Neo Renaissance, by the way. Check out our homepage, smAshomash.com. The link is right there for the Red Bubble Shop. Let's look at magnetic data. And we're seeing a spike happening just here at the moment, around midnight, actually, local time for the satellites there. Check it out, midnight for the GOES 17, seeing a big spike right there under the M. That stands for midnight. This is noon time for the local time for the satellite. Seeing a little increase in the magnetic fields there. So we're seeing an increase in we're seeing a shift in the BZ, part of the solar wind componentry. We'll get to that momentarily. First, a view of the top view ecliptic plane field plot. Earth remains in a South Pole current sheet shown here in red. There's a line of sight view. And there may be some North Pole current sheet headed this way, perhaps some activity kicking up in the southern hemisphere down there. We'll be keeping an eye on that, and when I say eye on, the pun is intentional. Line of sight coronal hole plot, you can see those rather not well-defined coronal holes in the southern hemisphere. They are now reaching across the equator, so we can expect some more solar wind from those, perhaps. They're just moving into the Earth-facing zone here at the end of this video. Keep in mind the data is nearly 2 hours old from when we took the video. Here's a close-up of the South Pole coronal hole systems. Great imagery there in 193 angstroms from the SDO. How about a full disk view? And you can see some North Pole-oriented coronal holes there as well. Not showing up on the PFSS data yet. Likelihood of major flares not there. 2897 and 2896 are both alpha class sunspots, and 2896 has been continuing to degrade. 2897 pretty stable. Here's the solar flaring over the past 3 days. No spikes in the proton flux yet. Again, coronal mass ejection warning in place. We may see some spikes in the proton flux, but probably not, because the likelihood of major flares is not there. So here we see the BTBZ just recently shifting into the negative, but it's not. We're not seeing a consistent negative signal here in the BTBZ. We are seeing a very high speed coronal hole wind stream here. So it's reached all the way up to nearly 700 kilometers per second there. There's a reading of 678 kilometers per second. Current conditions are more like 658 kilometers per second, so a very high speed solar wind. Solar wind density coming down off its highs here. We may see a further increase here in the solar wind speed. Anyway, the solar wind density about 9 protons per cubic centimeter. If we see a strong negative BZ signal form in here, we may go into geomagnetic unrest. Don't be surprised to see it happen. The current KP index is only at 2. And if we get a strong negative BZ, that could jump into geomagnetic unrest suddenly. You may see some auroras. Here's the magnetohydrodynamic pressure modeled over the past 4 hours. This scale is in nanopascals. Again, magnetohydrodynamic pressure. And again, we've got a high-speed solar wind coming in, which equates to high pressure. The density is just pretty nominal at the moment. Next, we'll look at ground perturbations. That was the Earth's magnetic moment from space out to several Earth diameters. Here it is on the ground level. Changes to Earth's B field, and check it out. There's a vortex happening over, oh my God, there's a vortex happening here over northern Canada. To quote Eugene Bagashov, we're all going to die. We're all going to die because of this vortex. Just kidding, folks. And since that refresh will let that play through again, this vortex could, who knows what could be going on. Perhaps there's a meeting of the Illuminati. Perhaps there is some sort of baby-eating Moloch ceremony. Who knows? Please consult the silliest channels on YouTube to figure out what could be the source of this scary, spooky magnetism. Perturbations at both poles from that high-speed solar wind. Like the last imagery, that, by the way, that's 4 hours of data. Geospace Delta B changes to Earth's B field. Here's a diagram of the solar system, and look at, there's a straight line forming. Look at that. It's not a very straight line, is it? Keep in mind, this is not to scale, folks. We're going to show you the solar system forecast here. Let me press refresh. Here's where stuff is now. We'll advance it 1 week to the 28th. There it is on the 28th. We'll have a gibbous waning. Crescent waning. Next, for all you astrologers out there, and by the way, astrology is looking more like science. The more we learn about astronomy, the more it looks like astrology in many weird ways. We'll have to make a video about that soon. Here's a star chart for what's going on over my head. Mars is rising ahead of the sun. And the moon is going into a setting mode now, still pretty high in the sky. Did you see our time-lapse imagery? We've got a time-lapse sequence that we took of the lunar eclipse from here in Lehigh Valley, Pennsylvania. Let's take a look at our coronal mass ejection watch, our coronal mass ejection warning. We'll show you what to watch the coronal mass ejection happen. It's coming. Whether it'll strike Earth or not's another story. We're just forecasting it before it leaves the corona. Here's the view from L5 and L1, the gravitational equilibrium points where stereo A and the SOHO are located. Stereo A on the left, the SOHO LASCO C3 on the right. Also, you got a view of Mercury here. And shout out to Gina Maria Colvin Hill, one of our favorite YouTube channels, pardon the sarcasm. She'll tell you it's a ship. Let's zoom in. As some of our viewers like to be scared of things that aren't scary, perhaps. So check it out. Oh my God. Look at that. Oh my God, it's a ship. If you consider a planet a ship, then yeah, Mercury's a ship. The reason, by the way, it appears so bright is because the coronagraphs are calibrated to see the corona. The corona is dim. See this area here? It's dim. Dimmer than this planet. Planets are bright. The corona is dim. The camera is calibrated to view not bright things. That's why this disk is here, to cover up the sun. You know, the brightest thing. Anyway, today's cosmology segment is going to be brief, and it's going to be integrated in the daily space weather video. One of the many reasons to watch our daily content. There are all kinds of cosmology tidbits mixed in, as well as playlists on the channel on YouTube, youtube.com/smashamash/playlists. Let's do it. We're not picking anything random. We're going to look at 3C405. This is the strongest radio source in the entire sky. It's not that strong of an X-ray source. Radio galaxies are typically galaxies viewed edge-on. Not a galaxy with its pole directed toward you, but a galaxy with its ecliptic plane directed toward you. These galaxies tend to be radio galaxies, and Cygnus A is the strongest radio source in the entire sky, except for one other one, the 10.7 centimeter radio flux source known as the Sun. Is the only stronger radio source in this galaxy. It's located about 530 million light years away. These are its X-ray outputs. It's a consistent X-ray source, and it's not real bright in X-ray. But check it out in radio. It's pretty spectacular. So here's this galaxy in radio, and I'm just going to look at some various different bands here from the low end of the electromagnetic radiation energy level, in other words, radio frequency imagery, because this is quite a spectacular galaxy. So this one here is 1,420 megahertz. Here it is in 35 megahertz. And the reason Cygnus A is called a radio galaxy is because of its strength in the radio bands. If you look at its photometric points, you can see it's got a ton down here at the low wavelength. Because it's a radio galaxy. And one of the many ways we catalog galaxies is the type of photons that they're sending. Let's check some other wavelengths. Here's a very interesting frequency, 21 centimeters. So it's probably not a coincidence that that's just almost double 10.7 centimeters. It's probably not a coincidence, folks. This is probably a bunch of hydrogen spectra. But anyway, check out how this galaxy looks in this wavelength. It's quite spectacular, as you can see. There's a huge source next to it there as well. Here's 820 megahertz. And I'll just click on some more here. 44 gigahertz. You can see the environment completely different at that frequency. 217 gigahertz. And it's a fairly well-studied portion of space because, well, there's a lot of stuff going on in the constellation Cygnus. Here's a 9-year survey, and you can see the way it's looking like a sphere in that particular spectra. Don't worry, folks, there's not a void there. That sky survey just lacks data for Cygnus A. Here's 30 to 44 to 70 gigahertz. That's a great radio view there. And by the way, all of this is the Milky Way galaxy's Cygnus arm, if you're wondering what that is. So let's switch to optical bands here. Here's the view from Pan-STARRS. So you can see the familiar shape of the Milky Way galaxy, and we're going to zoom way, way, way in, because again, this is one heck of a strong radio source, and it's located about 500 million light years distance. This is what it looks like in optical bands. And let's look at still additional frequencies here. This is the massive radio galaxy in infrared. And last but not least, how about an X-ray image? There is the X-ray imagery of Cygnus A. And if we zoom way, way, way out, this galaxy, also known as 3C405, if you zoom way, way, way out, you should see the Milky Way galaxy. I believe this is the Milky Way galaxy. But in any case, there is Cygnus A in the X-ray band. Switching up things entirely, and brace yourself. This is the astronomy picture of the day. And you can go check this one out yourself at apod.nasa.gov. Spectacular imagery here of a comet. And we're just going to slowly let this one scroll. Again, you can view this yourself if you like at apod.nasa.gov. There's the full image. Shout out to Dan Bartlett. Drop us a line. We'll feature you on the channel. That's today's cosmology segment. Again, check our playlists at youtube.com/smashamash/playlists. We do all kinds of things besides daily space weather. Back to space weather, here are charging hazards. And yeah, there are some minor ones on the surface of some satellites, perhaps in the central Pacific Ocean at the moment. Here's a 1-year chart of the relativistic electrons, which are involved in such things. That's from Solon.info. Here's the 3-day chart. The greater than or equal to 2 mega electron volt electron flux from the GOES 16 and 17. No warning levels here over the past day or two. And we are expecting some pretty high levels here. After the coronal hole wind stream subsides. I would tend to agree with that forecast. It might be a little bit later than that, but that's the NOAA forecast for relativistic electrons. We're next going to show you the total electron content forecast, which is about that area there between your GPS satellite and your handset. It'll show you GPS errors, where they're most likely to occur, and you can see some anomalies once again happening over North America and Canada. Also in the southern Indian Ocean around Madagascar, and around Antarctica. That's your total electron content forecast. Next, we're going to show you the ionosphere. Located about 300 kilometers, the F layer is the layer that we focus on. This is the portion of the ionosphere where the GOES 16 and 17 endeavor to make their measurements using radiography. We've got massive low-frequency anomalies all around the planet in the ionosphere. We'll show you the anomaly map next, after this plays through here. That's played through. Here's the anomaly map, showing you anomaly in megahertz from the 30-day median. Take note of the time and date stamps above the imagery. Lots of low-frequency anomalies around the South Atlantic anomaly, which is now over the South American continent, and massive anomalies in the Southern Indian Ocean, the Southern Ocean, Central Asia. Here's the latest image on the anomalygram. That's 11:15 Universal Time. There's the ionogram, and there's the anomalygram. We've got bonus features, starting out with a water vapor map. Yeah, that's not space weather. How about the El Teide ground-based solar observatory? Do you watch our meteorology segments? Are you aware that we do meteorology segments that usually premiere before the daily space weather videos? Check out the filaments all over the southeastern portion of the solar disk. Those are serious. And here's some additional bonus features. Here are some additional bonus features, I should say. There is the intensitygram. We'll also show the magnetogram. There's the refresh. 2896 continues to degrade. 2897 still pretty stable. It could be becoming a beta class sunspot again. I do see some little dark spots here. Despite all that, the likelihood of major flares just not there. Some possible new regions forming down here. We'll keep an eye on it. And when I say ion, pardon the pun. How about the GOES 16 SUVI? This is what we've been streaming on the Twitch channel. And thanks to everybody who discovered us via Twitch. The GOES 16 SUVI imagery automatically refreshes. And it's great at showing solar prominences. It has a rather wide field of view, making it even more attractive than the SDO in some ways. Let's go back to the SDO, however. Here's my favorite wavelength, 171 angstroms, and we'll zoom in on some filamentary activity here in this wavelength. Here's the southern hemisphere. The area to watch. We apologize if we may have experienced some technical difficulties. Here is the imagery we were referring to. $28.96, $28.97. Possible new area showing up over here. Here's the GOES 16 SUVI. And here are the 171 angstroms images to close out the video. Southern hemisphere. It's the place to watch. And here are some spectacular filaments and a great Earth scale there to show you the size of said filaments. Thanks for tuning in, viewers, and may that solar wind be at your back.